you can see that subtle effect that's happening. The problem is the render time's gone up an extra 30 seconds, and that's always going to be the trade-off between low quality and high realism. Just zoom in here. So it's a subtle effect, but it's also a realistic effect, and it's something I think you kind of need in all of your materials. Once you've got the structure of the material set up, it's pretty easy to change things. So we know that the reflection amount's not going to change now, so that's going to stay the same throughout. So you can go into here, you can copy that reflection curve, and you can just paste that as an instance. You'll notice I work in the old school material editor. I don't use Slate. Feel free to use Slate if you want, it doesn't really matter. Alright, so that top coat, just before moving on to metals, just going to tweak a couple of values just to get it looking a little better. It's probably not blended enough, so we want to slide this back a little bit and just set it to be a little bit higher than 0. If I ramp this all the way up, you'll see what happens in the material preview. We're getting more of that mirror finish and less of the matte finish. Just going to re-render again. So the difference is too subtle to realize in this plastic material. It's just not reflective enough to demonstrate that blooming highlight effect. So naturally the progression is to move on to creating metallic materials. So I'm just going to stop the video here and start up again, and we're going to create a metallic material using the same exact process, just using slightly different refractive index information, and I'm going to try and really highlight that effect of a blooming highlight. Just quickly before jumping into making a metallic material, I'm just going to drop back that slide in that you saw in the theory section just to reiterate what I was describing earlier. So now we've created the plastic material. You can see this blue curve, and now we're going to go in and create a metallic material. When you open up this starting scene, you'll see that there's already a couple of materials created for you. One of them is a gold material and the other is a silver material. They weren't designed to look like any real world material, but more so to show you how they're structured. So if we go into the silver material, you see that it's very similar to it's basically identical to the plastic. You've got a base coat, you've got two coat materials, and blends for each of those. Now the gold's identical again, except there's one key important difference when you're creating colored metals, and that's that the RGB component is split out. So if I go into the reflection amount here, you can see that there's a red, green and blue component. So I need to explain that to you. Now all metals do have a red, green and blue component. They're just very similar usually, like silver for example, so you can't see that colored tint in the reflection. But just the same way that you can blend the reflection amount based on the angle, you can also blend the color based on the angle. So where am I getting that information from? Well, we need to go back into the refractive index website. We need to change it to metals. And let's just go into aluminium. Now here's where we need to look a little bit more closely. And we need to understand what the red, green and blue wavelengths mean. So what I've done is I've done a Google search for red, green and blue, and on the Wikipedia page you can see the the value in nanometers of the wavelength for each spectrum. So the red wavelength is somewhere between 0.6 and 0.74 micrometers. If we go back to the Refractive Index website, this little symbol that looks like a U is just, in maths, it's just short for micro. So it's just saying the wavelength in micrometers. So if you go back to red, you can see it's going to be somewhere between 0.6 and 0.74 micrometers. So let's just put a value of like 0.68. If you put that value in and reload it, you'll see here that we're getting a value, a graph that looks very similar to that metallic example I showed you just before. Now we need to, that's what we're seeing now is only the red wavelength. Like I explained, each material is made up of red, green, and blue wavelength. So we need to separate those and see what each looks like. So if we go into the green wavelength, we can see it's got a value between 0.52 and 0.57 micrometers. So if we put in a value of like 0.54, we can see the green wavelength. And it looks very similar to the red. So like I explained, with silver materials and metals that are more grey, that red, green and blue wavelength is going to be very similar. That's not the case for coloured metals like gold. So if we go into gold and put that value of like 0.68 in again, we take a look. Now you'll notice gold's predominantly a red material, so as you'd expect, the red wavelength is highly reflective. So I'm just going to download a JPEG of that. Takes a little while. Now we're going to go in and put the value for the green in. Let's go 0.54. Reload that. Now there's less green showing because more red is absorbed. Just going to download that one. Okay, so you can see here we've got the red wavelength, we've got the green wavelength, and lastly is just the blue wavelength. So we go into the blue wiki page and we can see it's between 0.45 and 0.49 micrometers. So we'll just put a value of 0.47 in, just averaging that. And the blue wavelength is, once again, even less. So just download that. So there you go. We've got the 3 different wavelengths for gold. Now we can go into Max and reproduce that. So once again, just going to create a base material. For now, metals do have a subtle diffuse value, usually with a kind of grime texture, just because of impurities in the metal. I'm fairly certain though that 100% pure metals don't have any diffuse component. So in the reflection slot, we're going to use the same process as we did before. Going to create a fall-off material, keep it perpendicular and parallel, and this time, instead of using mono mode, we're going to use RGB mode. It's pretty funny. This is where I have to kind of thank John O'Connell, because when I was trying to come up with this process, we were actually blending 3 different materials with different red, green and blue components. So what we do is we'd make a reflection map, set this to green, and when you blend all 3 in a blend material, you end up with a white reflection. It was kind of labor intensive, so this way sorts that out. So if we go into the red channel, we can see that it's pretty much fully reflective the whole way out. So I'm just going to untick the green and blue channels, add a point here, and just slide it well and truly up. Make it a smooth Bezier handle. So there's the red component. If we untick the red component and go into the green component and check out that curve, we can see the starting reflection is just above 0.8. So we can slide this channel up, like 0.805 or something. Add another point in the center. Just double check again. And at about 60 to 70 degrees is when it starts blending. Now don't get confused, because in Max, this value on the right, which is the normal angle, goes from 0 to 1. In these graphs, it's going from 0 to 90 degrees, so it's not going to be identical. You're always going to have to push it a little bit further. So if it's starting to become reflective, more reflective at 60 or 70 degrees, we need to move this a little bit further. Now what you'll notice is we're starting to see some color in this reflection map. If I tick on the material preview, there you go, you can see that appearing throughout. Now lastly, we just need to go into the blue channel, and it starts out at about 0.4. So untick the green and tick the blue, and slide this up to about 0.4. Same process, add another point in the center, and it starts becoming a bit more, the blue wavelength starts becoming a bit more reflective from 50 to 60. So we can go about 0.55, something like that. And there you go. We've just entered in, if I re-enable the red, green and blue, you can see the three different channels creating that yellow tint seen in gold. Now don't take it too literally, because on the Refractive Index website, this was sampled on, this is giving you a pure scientific value for that metal. It might not exactly look like that in reality. So always base these values loosely. And if it doesn't look right, it doesn't look right. If you need more gold, or if you need more yellow in your material, go into the green and blue. And if you drop them down, you'll get more of that gold reflection color. So just eyeball it, do it to what you think looks right, but you will need to separate the red, green and blue to create those colored reflections. We're very close to finishing up this first video, but we'll just finish off creating this gold, and I'm going to create the exact same process, just go up to 128 on the reflection. Now one difference between plastics and metals is we need to use a different V-Ray BRDF. It's not ideal at the moment. Ultimately, what I'd like to see implemented is a GGX BRDF, and I was saying earlier how there's simple and complex BRDFs. What the GGX BRDF does is it does all this work for us. It simulates those multiple layers and the blending of glossiness based on the angle. So it's a lot more complex, but for now, with metals, Ward works a lot better than Blinn, and for plastics, Blinn works a little bit better. So always tick Fix Dark Glossy Edges, and in the options slot, make this 0.01, just so the reflection isn't getting cut off. So we've set it to Ward, and now we can make this base layer whatever you want, but I'm going to make it the same as what we did on the plastic, and set that to 0.6. And you can see we've got an extremely glossy metal. Actually, instead of 0.6, I'll go 0.8, just because it's extremely blurry. And I'm just going to tweak a couple of those reflection values just so we've got a material that's a little bit less reflective. Alright, I'm just going to assign that to the shader ball and render it so you can see where we're at. So there you go, you've got a material that does look like gold, but in the exact same way as the plastic, we've only got that fall off effect on the reflection and we don't have the glossiness blending. So I'm just going to recreate exactly what's happening in the plastic, but with these metallic values. So create a blend material again, keep it as old, just call this gold base, doesn't really matter, whatever naming convention you want. Just going to drag it in, gold, code 1. So the first coat material, we're going to go up to 0.9, and the second we'll go 0.99. Copy the reflection, make it an instance. I'm going to copy the reflection and paste it into here. Now, the difference is I've pasted that reflection in to the blend and it's got color in it. So that's not what we want. So the easiest thing to do is just to steal the reflection maps from the plastic and paste those in. So if we look at the quick material preview, we can see now that we're getting a blended specular highlight. It's going from glossy to very sharp, and near the edges it's becoming more of a mirror finish. So I'm just going to save this render and re-render with this new blended material applied. So I'm just going to compare those two now. And if I slide between them, the effect is a lot more noticeable this time, and we're getting a lot better result. So if you zoom in the details here, before the reflections appear very flat, now we're picking up a lot of extra detail that wasn't there before. So basically, to summarize, that's how I've been creating these materials for the last couple of months. The materials I released in that initial pack varied all over the shop because what you were seeing was a slow progression of the old method I used and the new methods, and it results in sometimes a bit of a messy material structure. So any materials you create from this point on should be roughly based on this idea of blending, setting the reflection amount correctly and then setting the glossiness correctly. You can of course use maps in any of these slots for the glossiness. For now though, I've kept it kind of very simple and very easy to understand so you can get your head around this material creation process. In the next video, we're going to go back into optimizing V-Ray in a more complex scene, and I will jump into a scene that was released by Peter Guthrie, so you can look forward to that. I just want to apologize for this video being so late. A lot of things came up that I didn't expect, but I'm back on track now. So thanks for your patience, and I look forward to releasing the next video very soon. Thanks heaps.